Okay, so welcome back. And now in this example, what we're going to do is we're going to do two of these examples, and we're going to use the addition principle or the addition axiom to solve for these. So again, what we're going to do is we're going to isolate the variable on one side of the equal sign, move everything else, and simplify everything else on the other side of the equal sign. So let's do that. So the first thing is, again, there's the variable. Here's the constant that's associated with the variable by addition. So what we're going to do is we're going to add the opposite of that number to both sides. Again, using the addition axiom, which is, again, or the principle of equality here. So what we're going to do is we're going to add -4 to both sides, right? Whatever you do to one side, you have to do to the other side. So we're going to add -4 over here. And so if we add down, we get x. These cancel out, equals, we get 8 plus a -4, right? And so we get x equals what? 4. And that's the solution or the root. Okay? So let's do some more. So here in this example A, we have x plus 3 equals 8. So what do? We find the constant that's associated with the variable, in this case by addition, and we're going to add the opposite. So we're going to add -3 to both sides. Or you could also think of it as doing the opposite operation, right? Because, oops. So for example, multiplication, division are inverse operations. They undo each other. Addition and subtraction are also opposite operations. They undo each other. So you could think of this as doing the opposite operation as well. So the addition principle can be looked at as in that regards as well. So in this case, we could add -3 to both sides, just like the steps tell us. Or we could look at this as, oh, we want to do the opposite of addition, which means we're going to do subtraction. And so we can subtract 3 from both sides. It's the same thing. Either you add the opposite, or in this case, you do the opposite operation. And so if you add down now, what happens is x, well, you get +3 and then subtract 3, add 3 and then subtract 3. Well, that's going to be, and that is going to be 0. And then 8 minus 3 is 5. Or 8 plus a -3, however you want to do it. So then the root here is 5. So the solution is x equals 5. Okay, so let's use the steps again. So part B, what are we doing? We're subtracting 2 from both sides. Or excuse me, we're subtracting 2 here. So there's the variable. We're subtracting 2. We want to move this over to the other side. So we're going to add the opposite. So the opposite here is going to be 2. So we're going to add 2 to both sides. Since we're subtracting 2, we want to add 2 to both sides. And so we get x equals 4 plus 2. So we get x equals 6. Okay? Let's do another one. Here we got 5 plus x equals 2. Okay? So again, we can rewrite this because it's a plus sign, so we could use the commutative property and just write it as x plus 5 equals 2, but that, we don't have to do that. So again, what's the constant associated with the variable? It's 5. So now to get rid of that 5, to move the 5 over to the other side, we have to do the opposite. So we have the +5 here, so we're going to add a -5. And so if we add down, we get 0 there, we get x equals -5, or, well, we could do this, equals 2 plus a -5, which then gives us a -3. So x equals -3. So see how so far what I've done is I've been isolating the variable on one side, and using the addition principle, or excuse me, the addition axiom to move the constants and everything on the other side of the equal sign, and then simplifying it. Okay, so last one. So we've got x minus 1 equals 10. So again, I want to isolate the x variable. I've got this subtraction here. So again, I want to do the opposite of this. So this is going to be plus, right? So if I change this to a plus negative, right, I could do that. Then this is going to be a plus positive, right? So if I add the opposite to both sides, I get x equals 11. Okay, so I could solve it this way too, right? As long as I have x on one side and everything else on the other side of the equation, it's a solution, right? So that goes back to that symmetry principle. Okay, that's it. Have a great day.